Hello, everybody. Good evening. If you're in India or Pakistan, I saw lots of people in the chat. I think from that region. Good afternoon if you're in the Netherlands, and good morning if you're in the US. Very pleased to welcome you to this webinar. We'll speak about AI as it is today, 2022. Right? We have 45 to maybe 60 minutes on the clock to discuss that topic. All the questions are welcome. If you have questions, please put them in the Q&A. I may have some questions for you as well during the session. The link for the certificate I will share in a bit. So it's a generated link where you can fill in your name and you get a certificate for joining. So that will show up. With that said, let's jump in. So very brief introduction. This is me. My name is Rens. I'm Dutch, born in 1984. So for the people quick with math, I'm 37. I have a beautiful wife and a 1-year-old daughter living here with me in Amsterdam. My background is as a strategy consultant, as a psychologist, and as a tech CEO, right? So I'm CEO of Kimo. Kimo is an edtech company that's active in India, also active in the Netherlands. And we teach people the latest technology domains, AI, ML, Web3, blockchain, metaverse, etc. I also studied at Harvard Business, did some finance degrees, and lots of things in AI, although that's a couple of years ago. So things move quite fast in this space. If you want to connect on LinkedIn, more than welcome, right? Always happy to speak with you afterwards. So let's jump into the AI space. One of the more, I would say one of the most interesting topics nowadays. Of course, if you're looking for a job, also if you're an engineer or an engineering student, AI ML has ample opportunities, right? Anywhere from data science to people with a PhD in natural language processing, what we're using here in Kimo. So lots of opportunities. But let's start with something simple. How much do you know about this already? And I'm going to pose you the question here in the Zoom call. So 1 means I know nothing. 10 means I'm an expert. So I wrote books about this. I completely get this topic already. Just to give me a sense of where you are, so I can tailor the lecture a bit to your level. I see there's 1 person so far that has mentioned 10, so lots of optimism there. And most people seem to be at the lower spectrum. So I'll give you a few more seconds to put your answers in. Okay, and not everybody is done, but I'm going to end it right here. So the results are that most people are in the 1 category. We have a couple, I would say 90% is in 1 to 5, right? So that's where we are. Okay. Thanks for that start. Let me give you a definition of AI. And before we do that, I want to start with what most people think AI is, right? And that is the associations most people tend to have with AI, which is, for example, based on movies. So if you haven't seen those movies, I would definitely recommend to, after this webinar, maybe download one of these movies and have a look, right? The Matrix, I think you know. iRobot, you may know her. Fantastic movie with Joaquin Phoenix. Westworld, great series. Chappie, Transcendence. But all of these movies have a very similar story, right? The story is you have human intelligence or biological intelligence, and at some point there is artificial intelligence which takes over and becomes dominant and actually starts ruling the planet, or at least starts ruling humanity. So in this 1 hour we have, I want to shift away from this. This is great, you know, get a beer, get some popcorn and fantastic movies to watch. But I want to have a very different conversation. I would like to deep dive into what does it actually mean in the market. So where do you make money with AI? What kind of economic models are associated with AI? What is the technology about? So what are we really talking about here? Is it only neural networks, or is it a broader spectrum? And what's going on the global stage? Why is this such a hot topic that China now has an AI national strategy? The US has an AI national strategy. Over 50 countries now have an AI national strategy. So why is that the case, right? So those perspectives, no Hollywood, but purely the facts on the ground. So what is AI? AI is trying to match or surpass intelligence that humans exhibit, right, in software. So either the goal is that you try to build something that is as smart as a human being, or as most people would probably say, including Elon Musk and other guys, you have to build something that's smarter than human beings, at least in specific spikes, right? Specific dimensions. So if you build a self-driving car, for example, obviously it has to be better than human beings, because otherwise, what's the point, right? And if you build a cancer classification system that can diagnose skin cancer, for example, it has to be better than a typical doctor, because if it's better, it has value. If it's not better, it has no value. So very simple. You try to mimic human intelligence or surpass it. But if you dissect that statement, you realize that human intelligence has lots of different subdimensions, right? So what do we use to be intelligent? We use memory, we use language, you use movements to get us from place A to B, to find rewards in our environments. Of course, vision, creativity, goal-driven behavior, all of that stuff is part of the system that we have. And that first line with those things, memory, language, vision, etc., that is stuff where we also have AI models that do quite a good job, right? We have really good vision models, we have really good language models, GPT-3, etc. We have, of course, computers can have really good memory, better than most human beings. And we're building the first systems that can actually show goal-driven behavior. And I'll show you that later in a movie. There are also other things, right? Consciousness, compassion, the experience of emotions, ethics, what is right and what is wrong, dealing with complex goals. Should I go for job A or job B? Or maybe job A is fantastic, but it will ruin my family life. So is it then still worth pursuing? That goal complexity that we have in real life is something we cannot really model yet in AI systems, right? So we don't have something that can mimic general intelligence or complex goals or ethics or emotions or consciousness. So a couple of check marks for where we are successful and a couple of crosses for where we are currently not successful. I think this is a good starting point. So if you talk about AI, we know it's about the digitalization of cognition, right? Trying to mimic human intelligence on silicon chips. But underneath you have subcategories. So AI is all the activities that relate to building intelligent software and maybe with that intelligent machines. But underneath that, typically people speak about machine learning. Machine learning is a system where you create models that learn from new data, right? So you have a model that is trained maybe to predict the difference between iPhones and Samsung phones or whatever your model does. And the more data it gets, in this case with labels, right? So you have a picture of an iPhone with the label iPhone, picture of a Samsung phone with the label Samsung, right? And the more data it gets, the better it becomes, without you going back to program that model again. So machine learning is a system that can work with feedback to improve the predictive accuracy by seeing more data. Underneath, you have deep learning. Deep learning is a way to build a model, not the only way, right? You can build a model anywhere from Excel to a piece of paper to a neural network. Deep learning is neural networks. It's where you have a particular infrastructure for a model. We'll look at it later. That is a bit similar to how we think the human brain works. So you have layers of neurons or nodes that are connected with weights, similar to neurons in your brains that are connected through synapses with certain strengths and weaknesses, etc. And then there's this whole functional specification where you can focus on language. We call that NLP, natural language processing. You can focus on vision. We call that computer vision, CV. And you now have the first models that can actually handle different senses at the same time. So maybe it can handle language and pictures as input to your models, right? So that's a more functional distinction. And you'll find in practice, for example, here in Kimo, we have only people that do NLP, right? We don't have anybody that's trained in computer vision. And those are actually different branches, right? There are different kind of infrastructures or architectures for the models. So that's the logic. AI on top, machine learning underneath, deep learning, all about mimicking the human brain, neural networks, and then functionally language, vision, maybe multimodal. Let's look at the market, and I'll start with your gut feeling. Maybe you already know where you can make money in the AI space. Maybe you don't. So how about you try to answer this question, right? So before we look at the market, where do you think you can make money in the AI space? So let's say you're a fantastic AI developer, you know about your neural networks, where would you move into? And maybe if you can share a why on the chat, it would also be fantastic. And meanwhile, I'm sharing the link for the certificates. Okay, so let's take a couple more seconds. I see lots of answers coming in. So where is the money in this space? Right, of course, AI is about mathematics. It's about Python. It's about R. It's about being good at programming. That's all nice, but where's the money, right? So let's close the poll. I'm going to share the results with you. And I think most people have said it's in enhanced analytics in marketing and sales. And those people are correct. So very well done. Only 9% of people said it's in optimization of factories, which is a shame. That's a very, very big chunk. And the others, yes, there's all value in the things you mentioned, but these are smaller chunks than enhanced analytics and factory optimizations. And I will show you that on this chart. So this is a McKinsey report a couple of years ago. And if you cluster where the money is going to be made, right, then you see there are two very big clusters here, the purple one and the gray one. And the purple one is everything that relates to understanding human beings, right? Personalized ads, customer service, which is AI enhanced, recommenders for the next product to buy, pricing and promotion strategies, customer acquisition strategies. All of this is understanding human sales and click behavior that you can improve through AI, right? It's a very big chunk of the total pie. The second big thing, and with these two, you already have half of the total value generation, is related to optimizing how we produce stuff, right? So maybe you have a factory, maybe you produce iPhones. Sorry, it's on my desk, so I just use the first thing that's nearby. What is the most painful thing that can happen to your factory? The most painful thing is when your factory goes down and is not running for some reason, because then your factory is still there, your people are still there, your robots are still there, but you're not producing anything. So what is the biggest value item that we can have in predictive software like AI? It's called predictive maintenance, which is which are systems that can predict when something will break down, right? So maybe in a particular robot, there's a vibration sensor and it tracks the vibrations. And if you start to see very big deltas in that system, then we know, hey, maybe this robot is going to break and it should be replaced before it breaks down. Because if it breaks down, then the entire factory floor will probably stop in that moment, right? So predictive maintenance is all about predicting when some item in a chain will break, and then you fix it before it breaks. So those are the very big chunks. All the other things you mentioned are also true, but if you look at where's the real money going, understanding humans, understanding sales, understanding clicks, optimizing how we produce stuff. Are there countries that make more money than others? By the way, if you think the slides are complex, sorry, I have a consulting background, so I'm used to making these slides. I will send them afterwards. So if you want to read this as a book, you can read them overnight. So you have them in your inbox as soon as we finish. This slide is saying certain countries will benefit more than other countries, right? If you're in India, maybe you feel that India is leading the race to AI. Maybe you feel you're at the bottom. Let me not ask that publicly, but most people in India I know will say we're not leading. We're somewhere maybe at the bottom, maybe in the lower half. The same we feel in Europe. Right? We feel that China and the US are leading and Europe is actually a bit behind. And I think if you look at the numbers here on the slide, this is the predictive value for China, for the US, for Europe. And you can actually see those numbers are also what economists predict. China is going to benefit most, then the US. And why is that the case? They were very early. All the national policies support AI development. All the funding, also the government funding, is really supportive of AI development. And laws and regulations are quite loose, right? So in China, for example, if you have 3 different data pools, healthcare data, education data, and financial data, you can pull them together and make a very predictive model. If you do that in Europe, if I would do that in chemo, I would go to jail tomorrow morning, right? So that is not something we can do here. It's forbidden. And in China, that is easier. It's also not evenly divided over industries, right? Some industries will just have way more benefit from this than others. So if you're in manufacturing, if you have a Tesla factory like Elon Musk, this is fantastic because it can optimize your factory on 100 different dimensions. But if you are an artist or you work in entertainment or recreation, you can see here at the bottom, there's maybe a bit of value. Maybe you can generate some art with the latest generative networks, but it's way smaller than this factory optimization. The AI market, if you summarize what it really is about, for those of you who are entrepreneurs or would like to be, right? Typically, people say it's actually quite close to the software market. So you make some kind of software which is AI generated. That typically has quite high margins, so it's an attractive model. So most of AI is technically just software which is smarter than before. And of course, there's this little chunk of hardware, right? So people also make special chips for AI, and the newest smartphones will have special chips to better run these AI-driven applications. It's also a bit of a weird market. If you're intellectually curious, and I guess you are, otherwise you wouldn't be here, then you'll find that the AI space, it's super competitive. At the same time, there's lots of open stuff, right? You can use lots of open frameworks, PyTorch, TensorFlow. You have lots of papers that have open code. So 50% of the papers actually have a code base, GitHub, for example, where you can actually explore how they made the models that they made, right? So that is quite interesting for me as a tech CEO, because you actually learn a lot from what other people do because they write about it. They put their papers on Archive, they put their code repos on GitHub, right? So it's partly open source, which makes it super interesting. And this, don't look at the numbers don't really matter, but this is the startup funding in AI, right? So I think you can see the colors are different quarters. So you can see that it has grown. In 2011, we had almost no AI startups, did not exist. Then it started to slowly appear. And in the last 5-6 years, funding for AI startups like Kimo, we're one of those, right, has really taken off. Quiz for you. So you know that funding is there. You know that certain governments also really promote AI companies. Can you give me one company name that you feel is extremely successful and is really an AI company? So what are we looking at? What are the names of companies that are extremely successful and that are AI companies? And I see some good answers. Tesla, DeepMind, Tesla, NVIDIA, Tesla, Meta, Mindtrace, Snapchat. Okay, so everybody, Tesla is the main one. Tesla is an automotive company, right? Which of course uses AI in the factories and in the cars, but it's not a company that only has AI algorithms that work for it. But fair enough. Amazon is a great example as well. Neuralink is another company from Elon Musk. IBM is okay, fair enough. Apple is actually a hardware company. Okay, so, but the examples you guys are giving are not bad, right? So Tesla is not an AI company, but they use a lot of AI. Google, you could argue, is even closer. Google is pretty much an AI first company, right? So most of the stuff Google has, for example, if you use Google search, how does that work? Well, you type in a query and Google adds 200 additional data points they have about you to that query to make it really rich and provide context, and then gives you the results. So very complex predictive model, AI-led, of course. So Google would actually be closer than Tesla, I think. But what I think is an interesting case, and I know it's blocked in India, but one of what I think is the most successful AI company of the last 2 or 3 years is TikTok, right? TikTok owned by ByteDance. Obviously, that's a Chinese firm, right? But why is it so successful? Well, TikTok is the fastest growing app in the history of apps. Over 2.5 billion downloads, right? So extremely successful company. And how does that work? It works with an AI algorithm that predicts the next movie you're going to watch, right? Super simple story. You cannot even type a search query. It just starts playing, and based on your behavior, where you spend your attention, if you swipe or not swipe, etc., it learns about your behavior. And why is that relevant? Because the 15-second videos compared to YouTube, 5 minutes, 10 minutes, 30 minutes, that system learns every 15 seconds, right? So it's really set up to learn very, very quickly about you, because every 15 seconds, it sends 10 new data points to the model, and it starts to model you and model your interest. So clearly, AI-driven company, clearly very successful. Is it ethical? Is it legal? I'll leave that up to you. So on value creation in AI, and this is for everybody that has maybe ambitions to become an entrepreneur in this space or build something in this space. Most people that I know, if you go into AI, they think they're going to build the next supermodel, not as in supermodel physical, but as a fantastic model with predictive capabilities, right? But in real life, that is not really as simple as that. So the way that you create value in AI is you start building. In the beginning, no one will care because your model is way worse than the average human being. And at some point maybe you get access to the right data sets, or you get lots of users that can provide you with labels, and your model gets better and better and better over time. And there's this key moment in the game where your model becomes better than the typical human being performing that particular task, right? And once that moment happens, that is the moment where, of course, you're sitting on a gold mine, because now you have an AI system that can do certain predictions better than maybe a medical doctor or a driver. And of course, your model is scalable to every smartphone on the planet, right? Which means it is extremely interesting. Example, the classic case by Stanford is skin cancer prediction. So how that works, you have little dots on your skin, right? And if you think you have skin cancer, you can go to a doctor, and the doctor will then classify, is this cancer or is this not cancer? So simple A/B classification. And doctors have a certain accuracy in this task, right? They get trained, of course, to do this. I don't know the accuracy, but let's say it's 80%. So 80% of the time they're correct, and 20% of the time they make a mistake. The mistake is very costly, because if you send someone home who actually has skin cancer, obviously it's a very, it's a serious situation. So within a couple of weeks, people in Stanford got lots of data from skin cancer classification data sets from doctors with labels, which were verified, and were able to build a model that is better than the typical doctor at skin cancer classification, right? So that's how this game can work. It's classification. If it gets to be better than a doctor, you have created lots of value. If it's worse than a doctor, you have created no value whatsoever. So very non-linear in the value creation. Technology is a space that is moving extremely fast. So what you'll find typically is that everything moves at like 40% year on year. That's Moore's law, right? So everything changes, gets better at 40% year on year, which is really, really fast compared to everything else. And that means if you're studying, like me, if you're studying AI or metaverse or Web3 or blockchain or any of those topics, it actually means you're studying every day, and you'll keep studying every day, because if you take a break for 6 months, the world has moved on and you have fallen behind, right? It's also why it's quite hard to explain how fast your world is moving if you're in tech, and you need to explain that to your parents or to people living in different industries. So super fast moving world. And if you look closely, and this is a graph from MIT, and I really like this S-curve situation, because overall it's growing really fast, but under the hood, you will see that quite often the growth for a particular technique or a particular system actually flattens out, and then people jump to the next technology, right? So you move from technology one, vacuum tubes, which has a limit, to transistors, which has a limit, to integrated circuits, which has a limit, and then the next thing will come. So actually, it's very fast moving, but people also abandon stuff that is no longer giving them the improvements that they need. And especially in language, so the area where we are focused, the improvement is faster than 40% per year. It's close to 100% year on year, right? So very fast moving area. And the same you can say about how quickly do people adopt new things. In the past, if you were the inventor of a light bulb or a radio, before you could convince the entire world to use your product, it would take you probably 100 or 150 years, right? You need to ship it physically. Everything is pretty hard. Now, TikTok, 2.6 billion people, 2 years, right? So the adoption rate moves way more quickly than before. And of course, for AI, that means your data generation, the amount of data that you get with which you can make your models better, is also coming in at a very different pace. One last thing about this market, and the first half, by the way, of this lecture is a bit heavy on the slides. The second half is more visual with videos, etc. One last thing on the AI market, right? AI is a market that, if you think about it as software with a bit of specialized silicon with hardware, that's fine. But there is a hidden market behind lots of the AI work, which is data labeling, right? It's labeling cats and dogs, stopping lights, zebra lanes, etc. Everything that needs to be labeled for self-driving cars, for resume enhancement, AI systems, etc. So these labels, in this case, you see people labeling skills in a particular text. Here you see people providing labels for self-driving vehicle software, right? So this is a car, this is a sign, etc. This is image annotation for satellite pictures. So this is a house, this is a swimming pool, etc., etc. So that labeling is a very big market that is sort of hidden, but is necessary to train the AI systems. So they're trained on human labels. And that's also how most of the bias gets into these AI systems. If the human labels are biased or racist or gender specific, that's how they flow into AI systems. Okay, Tech, let me quickly look at a couple of questions. Your audio isn't clear. I hope it's better now. Can I get a recording at the end of the session? Abdul is asking. No, sorry, because we're not recording today, but I can send a recording of a former session, which is similar. How is AI used in instrumentation engineering? I'm not sure, Deep Mukherjee, if I know what you mean. Maybe you can clarify that question and I'll get back to it later. Can I get a certificate? Yes, please use the link. Okay. Can you explain what is GitHub? Of course. So GitHub is a company now owned by Microsoft where you can showcase and store your code. So you can try it. It's free. So go to GitHub, make an account. It's the place where lots of people show their repository of code. And a couple of questions about chemo. Can we get the slides? Yes. Okay, how do we trust automated labeling? So this is actually a smart question, and this is a bit of a deeper question. So what I just mentioned is that a lot of the AI things we have today use labels, right? Simplest example always is cats and dogs. And most of these labels are given by human beings. So there's also systems in place, for example, with semi-supervised learning, which are more sophisticated. You have maybe a small set of labels, and from the small set of labels, we actually generate a larger set of labels for the entire database. So you actually generate the labels you have, you use the labels you have to generate a larger set of labels. In that case, of course, you're actually creating the labels also with AI. So it's possible, and there's more and more people looking at that because the labeling part is the harder part here. And of course, you would actually need to manually check if the labels you generate have the quality that you need, right? Because there's a risk there of going into a circle where you generate the labels, you train the model, and you keep doing that, and it doesn't get better because your whole system doesn't work. But it's possible to also generate labels instead of getting them from human beings. Let's look at the tech side of the equation. So we're talking about AI. You know, AI is the broader category of building intelligent software, mimicking human behavior. If you actually look at the tech stack that you need to do this, you can see that this is not only about building smart models, right? This is also about cloud computing, because where are you going to run those computations? It's not on your laptop typically, it's not on your smartphone. It will typically run in Google Cloud, AWS, Azure Cloud, right? So you can see that the cloud compute is going up. That of course means that also the amount of data that we're producing is going up. The number of IoT connected devices that we have is going up. And therefore, as completely in sync, this AI market is going up, right? So with the compute from the cloud, with the additional data that people produce or the devices produce, we can then make the predictive systems that we call AI. And this is how the cloud actually looks like. So I saw a joke online the other day where people were saying, there is no cloud, there's only someone else's computer. Well, the cloud is someone else's computer, right? In many cases, that computer then belongs to Google or AWS or Microsoft. And this is an example of a really powerful system that Google has. These are TPUs. So these are sort of like graphic processing units, which are enhanced for AI computations, which are very efficient and really, really fast. And how they're different from your CPU in your laptop, they typically handle matrix sort of multiple data streams at the same time in parallel better than your CPU. We have the same kind of things here in Amsterdam. They're literally in some places under the floor in the city. So we have these NVIDIA 800 chipsets. They float in oil, and the oil gets heated up by the use of the chipset. The oil then heats up the water, and the water then heats up the city, right? So you can see these data centers, which look like this, and maybe have these chips inside, are actually the building block of this whole AI revolution. And you see similar things happening inside of smaller devices. So maybe inside a door, inside an airplane wing, inside a car, there will be lots of little devices that can handle simple neural networks like this edge device. And why is that relevant? Because the computation is then done locally inside that car or inside that smartphone or inside that airplane. If it's not done locally, you need to send it to the cloud, will take time, needs to be sent back, will take time, right? So some of that AI compute is actually happening in the machine, and some of it is happening in the cloud. And we call that split the chip. So you have a chip in both areas, and you split where the computation actually happens. And one of the best examples, I think, of this an AI-enhanced tech we're seeing now is Google Pixel 6, latest device by Google. And this chip that Google put in is actually a chip that's very similar to the chips they use in here, but then, of course, much smaller. And it's actually enhanced for AI applications. So if you use Siri or Alexa or anything in that regard, if you use it on that phone, it will actually work much better. It's smoother, it's faster, because the phone is actually engineered to work well with AI applications. Quiz for you. So I'm not sure how many people here are developers, but if you build a model, and a model you always build to be able to predict something or generate something like art, what takes most of your time? So maybe give me a couple of answers on the chat. So what do you think, if you make a model, what is taking most of your time? So data collection and labeling, data cleaning, processing, research, algorithms, marketing, labeling, testing, writing the code, research, okay, labeling. I think people are all over the place with the answer. So thanks for that. Let me make that very everything will take writing programming lines. So the story is the following, right? This is the full data pipeline that you typically use if you build an AI system. So made it very simple for you with 7 steps. First, you need to collect data, right? Then you need to prepare your data, you normalize it, you standardize it, you make sure it's, you remove the dots and the dashes and everything that needs to be out. And that system typically is 80% of the time. Why? Because quite often you don't have the data, or the data exists in lots of different formats. Or if you work in a company, it exists in 50 different Excel sheets that are owned by different people who have a different boss, right? So before you actually have your data set complete and prepared, that is most of the time. And if you see a company that tells you, hey, we can have an AI model for you within 2 weeks, a couple of companies do that. Yes, they can, but they mean after you gave them the full data set in the right format, right? Because they know actually in most times it takes way longer because the data collection is so hard. Choosing a model is not so difficult. There's even lots of systems that can help you pick the right model. Training the model is literally enter and you wait, right? Assuming you use some simple frameworks, Keras, PyTorch, etc. Evaluating the model is quite difficult. It's not always straightforward. For example, in Kimo, we have a system that can answer questions from students. So it's not a simple cats and dogs classifier. Well, how do you determine if the answer was good or bad? You can ask human beings to give you that answer, but quite often you try to standardize the quality metric that you want to use. And it's relatively challenging sometimes. Then, of course, you start tuning it. So you actually make a couple of changes and you do the same thing again. And you end up with a system that can actually make the inference, the prediction. And what you're seeing nowadays, these are the steps that every developer goes through. And every step of the way will now have companies that will make this better and smoother and more effective. And the simplest way I think we're seeing now, and we call this democratized AI or AI for everybody. You don't have to be able to code. The only thing you have to do is drag and drop these little cards into the right place. So this is a low or a no code platform that has as a function to allow everybody to make an AI model without Python, without R, without MATLAB, or any software that you can use, right? So this is becoming popular now in organizations because it allows more and more people to try to build AI models without actually learning how it works. Let's jump to models, right? In the beginning, I mentioned AI is about prediction, and deep learning is very popular, and deep learning is about neural networks. And neural networks today, of course, there are lots of different other model types you can use, but neural networks are very popular because we think that's how biology, how nature has engineered intelligence is through neural networks. So they have a very fancy, popular vibe because we think that's the best intelligence we have, so we should learn from that. So how does a neural network learn something? As always, right, AI is about prediction. So let's predict something. Let's predict whether this is a cat or a dog, or whether this house has a particular price above or below 1 million euros. This is an example of a neural network. In a neural network, you can have lots of different input data. So maybe for the house, you know how big it is, you know the location, you know how old it is, and 50 other dimensions. You can put all of those things at the same time into the network. And the network is smart enough to figure out if there are relationships between those dimensions, because this is dimension 1, dimension 2, dimension 3. But in the deep layers, this is the first example of a deep layer, it can calculate all the correlations between those dimensions. So maybe dimension 1 and 2 have a correlation, and then it becomes a different prediction factor. 1 and 3 may also have a relation, becomes a different prediction factor, right? So the value is in, it can handle limitless amounts of dimensions. It can calculate the correlations between the dimensions. And of course, it can handle the feedback loop. So if it predicts the house is 1.1 million and the actual price is 1 million, then the delta is 100K. And that delta is fed back to the system as an error signal, like not good enough. And then all the weights between these neurons will be changed until your model matches the data. So that's how a neural network functions. Let me show you how it looks like for a very simple task. This is where most people start their AI journey. It's learning to predict a handwritten digit. 1 to 9, right? So what did someone write down? Is it a 1 or 2 or 3 or 4? And this is an example of a neural network. So what you're seeing is a simple multi-class classification task, right? It can be one of those numbers. And on this side, you see the handwritten digit that someone put in. And if you think how is this relevant, well, think about your mail, right? The cards we write to each other. This is what the postal service will use to classify what people actually write down, right? So it needs to be accurate. Otherwise, we cannot classify the numbers. But you can see here, and most interestingly, you can see all these layers of the neural network and the complexity it can handle. And this, by the way, is a super simple neural network for a very simple task with just 2 hidden layers, right? So there's almost no richness, but there can be thousands of hidden layers. There can be billions of parameters, right? So this is super basic, but of course, the state of the art is very different. Okay, so however nice that may be, that is literally 1990 AI. So MNIST, handwritten digit data set, 30 years old, great, but outdated. So where are we today? What is AI anno 2022? Today we are at a state where we can actually mix AI with physics engines, metaverse, where we can generate art, where we can have human level conversational abilities. And I want to show you a couple of those. Let's start with complex problem solving, right? We just mentioned AI can be very simple, just predictions. But here you can see that an AI system with a similar infrastructure, also neural networks, can also learn from rewards in an environment, how to do the right moves by training against another AI. And actually now they're starting to solve 3D problems like we do as human beings. Have a look.
On Earth, the simple rules of natural selection and competition led to the evolution of increasingly intelligent life forms. Today, we ask if comparably simple rules and multi-agent competition can also lead to intelligent behavior in a new virtual world. These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution. The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps. However, after many millions of rounds of having their shelter breached, the hiders learn to take away the primary tool the seekers have at their disposal. Note that we did not explicitly incentivize any of these behaviors. As each team learns a new skill, it implicitly changes the challenges the other team faces, creating a new pressure to adapt. So how do agents acquire these skills? They're trained using reinforcement learning, an algorithm inspired by the way animals on Earth learn. The agents play thousands of rounds of hide and seek in parallel for many days. They train against each other, as well as past versions of themselves, using an algorithm called self-play. Coevolution and competition on Earth led to the only generally intelligent species known to date, humans. While this world is far less complex than Earth, we have found evidence that simple rules can lead to increasingly intelligent behavior from multi-agent interaction.
Okay, so I hope you could appreciate what you just saw, right? So every little puppet has a neural network inside their brain, right? And they have certain perception abilities, right? They can actually see maybe 5 meters ahead of them. And they are not programmed to win the game, right? They're only incentivized to win the game. So they have certain things, we call them effectors, right? Certain things they can do, they can run and they can push and they can pull. So they have, let's say, 5 behaviors they can do, and they get a reward if they win the game. And the neural network then learns what is the right sequence of steps and behaviors I should do in this environment to win the game. And the cool thing in this situation is there are 2 AIs. There's the blue and the green AI, and both learn to get better. And both actually compete like I think human beings compete in real life for jobs or other stuff. And they get smarter because they need to get smarter because the other side gets smarter. So similar idea, neural networks, they learn patterns. In this case, they learn behavioral patterns that give them the highest reward in this particular environment. And then with an additional twist, there's an opponent and they have to learn to get better than the opponent. But this is an example of the same logic applied to a very different, way more advanced topic. I want to show you more, right? Because in the example I used, I said typically AI is used for classification, cats or dogs, A or B, or regression, like the house price is 1 million or 2 million or 3 million, right? But nowadays we are at the stage where we can also use AI to create content, whether that is pictures or that is videos or that is music. I had a musician here a few months ago, a fantastic guy from Munich, who has a PhD in natural language processing. And he actually figured out how to use the same models for musical data, right? For how do you call them? Notes in music. And now he makes money selling music albums that are generated by AI. So he's a musician, but he actually programs the system that makes the music and then sells the music and gets the money. So super smart. I want to show you one of those examples. This is.
Have you ever seen a polar bear playing bass? Or a robot painted like a Picasso? Didn't think so. DALL-E 2 is a new AI system from OpenAI that can take simple text descriptions like a koala dunking a basketball and turn them into photorealistic images that have never existed before. DALL-E was created by training a neural network on images and their text descriptions. Through deep learning, it not only understands individual objects, like koala bears and motorcycles, but learns from relationships between objects. And when you ask DALL-E for an image of a koala bear riding a motorcycle, it knows how to create that or anything else with a relationship to another object or action.
Okay, so I think you could see here now this system, you give it a prompt like koala bear riding a motorcycle, and it understands the text and is able to, based on the text, generate a picture, right? So it's multimodal, it's text as well as a picture. And you could see the infrastructure for it is still a neural network. It's still the same logic. If you like to try this, right, you don't have to code. You can go to DALL-E 2 at Hugging Face, for example, or you can go to Midjourney, where you can literally try this through Slack. I did the same. I gave a couple of prompts to Midjourney. So can you paint my dream house in the mountains? This is what I got back. Can you paint the AI system behind Chemo? Well, this is what I got. Not sure if you like it. And can you paint my daughter in 2050, right? My daughter is 21 months, so almost 2. And this is what the system thought my daughter would look like, what is it, 30 years from now. So let's do a last video. And I think this last video is fantastic in terms of what it shows. Because typically in India, if I ask people, do you use AI? Yes, sir, I use it because I use it for Alexa or Siri. So on that language front, I want to show you the latest model that, in my view, is very close to human level quality in speech, better than Alexa, better than Siri. And how is that done? They do it by training on actual human language, including the breaths, the size that we have, maybe the giggles that people have, right? So they include in the training data all these human elements that so far were left out. And now suddenly we have a system that sounds very much like a human being.
Hi there. I'm not really sure how to start this. I wanted to talk to you about something we're all looking for. I want to talk about love. I get it. It's kind of awkward. How do you connect with another person? Finding that common wavelength and really connecting. A connection that could turn into love. What could I do to make you fall in love with me? Would you need to feel my breath against your cheek? The soft touch of my fingertips? Laughing at that face you're making right now. I mean, I think I love you. I love you. Is all you need to love me in return the sound of my voice? Well, I hope that's all you need, because that's all I have. What you're hearing me say was never said by a human. It was generated by a computer. I'm not real. I was never born. And I will never die, because I do not exist. I know. Sounds like something out of a movie, right? But it's real. So, could you love me? What do you want me to say?
Okay, so this company was just bought by Spotify. So I'm not sure if they're still, if you can still try them, but you can see the quality of voice they can make, and they did this with a small team, right? This is not Google or Facebook. These are 20 guys that just purely focused on the quality of the interaction. If you're like me, I think this is fantastic. I think she sounds very, very human. I'm also curious if the question she asked, could you actually love this lady given the quality of the voice. Let's say you would only have the voice because it's quite convincing, right? It's not, it doesn't sound very robotic. Okay, let's go to the last bit. I have 2 more notes and then I'll answer a couple of questions and then we close. So in the beginning, I mentioned this Hollywood story, right? With Terminator, with Westworld, with all these scary pictures. And they are scary because they typically assume that the AI will have a general intelligence. It will be able to walk, to see, to speak, to do everything at the same time. In practice, though, it's quite a different game, right? Because models that do something are typically not linked to models that do something else. So if your model is really good at stock price prediction, fantastic, but it will typically not be able to speak or walk or see or anything like that, right? So what is relevant here is in AI today, we always focus on narrow predictive areas. So it might be really good in pronouncing language, what you just saw. It might be really good in classifying cats and dogs, but we cannot really combine that into one brain. So there is no such a thing as general intelligence at this point in time. So I'm not too keen on those Hollywood stories where this is the pitch. I think it's really far from where we actually are today. Geopolitics, as mentioned, right? You can see that lots of countries are now trying to build the biggest, most expensive AI model. First, we had models with a couple of million parameters. Now we have models with over 1.75 trillion parameters. So they get bigger and bigger and bigger, these neural nets. And they're called large language models, LLMs, right? Or foundation models. And this is what's going on, right? Everybody's trying to really push the boundary. Training that model once, even though the quality might not be good for that training round, is more than $10 million, right? So this is a big company or government game. This is not for normal people. And you can see, as mentioned in the beginning, this is how often AI was mentioned in Congress in the US. A couple of years ago, never. No one cares about this. And now we see that that has exploded. 50 countries have an AI strategy. In some cases, that is actually pitched as existential, right? So China and the US frame this as an existential race to like a bit of a war that you need to win this game, otherwise you will lose and other AI will dominate you, right? So if you read closely what they say, the country that wins the race in key technologies, such as AI, will be the superpower of the future. So whether you agree or not, but this is how it's perceived politically. So far, what's next? What are you going to see in the next years? You'll see lots of companies focus on data quality, making sure the labels are there, the right quality of data is there for AI models. You'll see lots of specialized chips and silicon in your cameras, we have doors here with facial recognition, right? So all of those chips will be, of course, become GPUs or TPUs. They will be AI optimized to run better for AI systems. You'll see more physics engines linked to AI. So optimizing factories, optimizing metaverse environments like NVIDIA Omniverse. You'll see more models that are able to handle multiple content types like text and audio or text, video, audio. And of course, we'll see a big push for efficiency because we want those models to also run locally on smartphones. So far, a couple of questions and then we close. I have lots of questions about how to become a Kibo CEO. And Ali, thanks for asking that. The answer is just start the company, right? No one will make you a CEO of a company unless you start your own company. So, and of course, that is a very painful road. So I'm not going to explain the whole journey, but if you want to be CEO of a company, the easiest way is to start it yourself. What is the best AI that I use and why do I think it's cool? I really like AI in search engines and in recommender systems, YouTube, Spotify, Gmail, etc., because I think it's really useful. It's also dangerous. It has a link to bubbles, right, where you get to see the same stuff over and over again. I'm quite fascinated with the AI that NVIDIA is making together with Mercedes, the car maker, for automated driving, of course. Why? Because it's quite unique in the way it's set up. So, for example, for every system inside the car, there's more than 18 data points that come in, cameras, LiDAR, radar, other sensors, and they all feed into the same model. And then they make the prediction, of course, for the steering wheel and the brakes. So I like to see how that will evolve. And I'm very keen on what I just showed you, that human interaction dimension, because I think we're now at the stage where it becomes almost human and therefore quite a bit more emotionally linked to how we as human beings perceive the world. How to start a career in AI? It's a difficult question because it's a very long path, but I would say most companies nowadays in AI use Python. Maybe they use R, but Python is very much preferred here, at least in Europe and in most of the US, I think as well. So I think you need to master Python. You need to master matrix calculations, those basic things. You need to understand them to understand neural networks. And then quite soon after that, I would not really go into the math all the way. I don't think you need it. I would actually really try to experiment, write your own code, make your own models, use PyTorch, which I think is pretty good, or use TensorFlow, or you even use Keras, which is typically simpler, and get some GitHub repos with existing models to actually train yourself. I think that's a good way. But start with, if you don't know how to program in Python, then you're definitely gone. So I would start there. How can I get the slides? I will send them over. Neural networks, I hope we have discussed enough. What is a reward for AI? Martin is asking. It's a smart question. So I mentioned these little neural networks, these little puppets, they can walk around and have a reward, right? I think a reward for us in real life might be a cookie or something sweet or something beautiful. For an AI, it's a programmed reward, right? So typically it's just +1 in the reward stack that they keep track of. So it's just a programmed +1, +2 thing that they're trying to optimize. Kindly share a no-code platform for AI. I'm a non-computer scientist person and will use it for my projects. So try C3 has Ex Machina, that's one. DataRobot also has a nice one, which is, I think it's even better. So maybe go with DataRobot, try to log in. That's a no-code platform. You can select different models very quickly. You can evaluate models very quickly. What do you think? AI can replace human intelligence? Shamsa is asking that. That's a deep question. Shamsa, honestly, I'm a psychologist by training. Yeah. So the first thing that will happen for me is that AI will replace human intelligence in lots of different narrow areas, right? Like self-driving cars. And you have to imagine what will happen if these self-driving cars get better than human beings. At the moment, they are better, let's say 200% better, 300% better, with fewer accidents, fewer deaths. At that point in time, it becomes almost unethical to let humans drive, right? Because they will actually kill more people if you don't let it be done by AIs. So I think we'll see a place where lots of things are in narrow branches are done by AI. And then you have a situation where most of the decisions in real life are actually done by humans plus AI. So maybe the doctor uses the AI system to classify for cancer, but then we'll still have the conversation with the patient. One decade or 2 decades after that, I think that might actually change to quite some AI replacing human intelligence. I think we may go in that direction. I don't necessarily think it will be general intelligence as it's pictured in the movies. Okay, I think we're how to apply for a job in chemo, and not in the webinar, please. Can you explain a bit about general AI and when that will come? So general AI is the notion that you can have all of these intelligence layers. Let me go back all the way to the beginning. It's a nice final question. General AI is the logic that you can combine all these different models, these different intelligence types in one system, right? Like a human being. We can speak, we can walk, we can see, we can predict the price of a house if we know where it is, etc. So that's all in one brain. And that is what we call general because it has all of these things in one. What most scientists think when will AGI or artificial general intelligence come is between 2030 and 2050. I'm not necessarily a believer of that, but that's what the consensus is right away at this point in time. But for example, it means that we need to solve a lot of those things here in the bottom, right? It needs to have some link to emotions, at least understand them better than what it does now. It needs to have ethics and goal complexity, because without those things, you cannot make most of the decisions. Maybe it's conscious, maybe it is an equivalent of that. It should have some kind of compassion to deal with human beings. And so far we are very, we're not there yet, right? So that is what it means. It means a general system that can do all of those tasks, but this is the bridge we still have to do. Okay, I'll stop there. Thanks for the time. We are right on the 60-minute clock, so fantastic. Thanks for the attention. Hope to see you again. Ciao.